Hello dear students. Now let us have a look at the question. So in the question we are being given that if initial velocity of a particle moving along a straight line, right? The particle is moving along a straight line with constant acceleration. Okay. Constant acceleration is an important word over here. And the initial velocity is 20 plus minus 2 meter per second. If its acceleration is 5 plus minus 0.01 meter per second square, then the velocity of particle with error, okay, the velocity of particle with error after time t equal to 10 plus minus 1 second is. Now let us move to the discussion slide to know the correct approach for this question. You see that initial velocity is having a value of 20 and the error in the initial velocity is 2, right? The acceleration is 5 and the error in the acceleration is 0.1. The time is 10 and the error in the time is 1. Okay. Now v is equal to u plus at. It is valid for constant acceleration, right? V is the final velocity, u is the initial velocity, a is the acceleration, t is the time taken. Okay. Now v, what is the value of u? It's 20 plus what is the value of acceleration? It is 5 and time taken is 10 seconds. So it is 20 plus 50, that is equal to 70 meter per second. Now our question doesn't end here. We need to find the error in this final velocity. Okay. You see that v, it is equal to u plus at. Let us denote the error in the velocity as delta v. Okay. And let us take this product of a into time as z. That is, we have taken the product of acceleration into time as z. So this equation can be modified as v is equal to u plus z, right? Now the absolute error, that is delta v, it can be written as delta u plus delta z. Okay, this much we know. And the value of delta u, that is the error in the initial velocity, is 2. But what about the delta z? How to find the error in the product of acceleration to time? Now z, it is equal to at, right? So the relative error in z, that is delta z upon z, it is equal to delta a upon a plus delta t upon t, right? Delta z upon z, it is equal to delta a upon a plus delta t upon t. Now from this expression, delta z, it can be written as z times delta a upon a plus delta t upon t. Okay. Now delta z, it is equal to, what is the value of z? Z is the product of acceleration into time. The value of acceleration is 5 meter per second and the value of time taken is 10 seconds. So a into t is what? 5 into 10, that is equal to 50. So delta z, it is equal to 50. What is the error in the acceleration? It is 0.1. What is the value of the acceleration? It is 5. What is the error in the time? It is 1. And what is the value of time? It is 10. So it is equal to 50 into 0.1 into 0.2 plus 0.1. Now it is equal to, as we solve this, delta z, it is equal to 6, right? So what is delta v? Delta v is delta u plus delta z, and we know that the value of delta u is 2, and what is the value of delta z? It is 6. So 2 plus 6, it is equal to 8, right? So the complete expression of velocity with error can be written as v, it is equal to 70 plus minus 8 meter per second. Now as we move through the options, we see that our fourth option is our correct answer, right? That is 70 plus minus 8 meter per second. I hope you understood